Okay, final of the three laws to look at where one is being held constant. Notice here, Gay-Lussac's law states P1 T2 equals P2 T1. Again, that is not a typo. The temperature has an opposite subscript as the pressure or volume it's next to. As you can see here, this time we're holding volume constant because it's not represented. Therefore, volume will remain constant or the same. Okay, determine the pressure change when constant volume of gas at 1 atmosphere is heated from 20 to 30 degrees Celsius. Have to convert both my pressures, both of my temperatures into Kelvin, convert both of my temperatures into Kelvin. My generic formula is P1 T2 equals P2 T1. I know that this is my 1 to 2. That makes the most sense because it's going from one temperature to another. So I put in my P, this should be P1 here. That's a typo. Let me fix that. Okay, so this is my initial pressure, and I know that it's going from 20 to 30, so P1 is 1 atmosphere, and T2 was converted to Kelvin of 303.2 Kelvin, and then P2 is what we're solving for, and 293.2 Kelvin is our T1. So looking at the things I have two of, I have two temperatures. They're the same unit, so they're good to go. Otherwise, I would convert one to the other. If they weren't in the same unit, I'm going to multiply the left two numbers, divide by this number on the right. When I divide 293.2 K over, my Kelvin units cancel, and mathematically I get 1.03 atmospheres. Okay, example number 3. A gas has a pressure of 6.99 millimeters of mercury at 40 degrees Celsius. What is the temperature at standard pressure? Okay, so we know these are together, so I made them 1. I have to convert my temperature into Kelvin as we always do, so I did that there. P1 T2 equals P2 T1. 600 millimeters of mercury is my P1. My T2 is what I'm solving for. And then there's another phrasing here that's a little new to us, standard pressure. If it says standard pressure, remember, you pick a pressure of the standards, which you have on page 2 of your packet or you saw in the beginning of Dalton Law notes. So I'm going to pick one of the standards, okay, 760. Why 760? Because I already have units of millimeters of mercury. I want to have the same unit of pressure because that's what I have 2 of. So if I picked 1 atmosphere here, for instance, then I would have to convert it. So why convert it when I can just slide the correct number in? So you're going to pick one of the standards from the list of standards, and you're going to divide them. So you're going to multiply these numbers on the right this time and divide the number over on the left. When I divide 699.0 millimeters of mercury over, millimeters of mercury units cancel, and mathematically I get then 340 Kelvin because millimeters of mercury cancel, and the math would give me 340 Kelvin. Just as a note here, I did the math on my calculator again after creating this slide a while back, and I did want to fix this number. 340.5 would be proper sig figs with this math. Okay, next example now. This is not numbered. You're just going to have to follow along and find the problem in your notes. It should be the third one on the page for, Gay-Lussac. So as I read this, I see this is a P1 and a T1, or at least I see this is a P and a T. Maybe better even said, we're looking for final pressure, so that we're going to make that a 2. So I know this is a pressure, so it's P1. Standard temperature, remember, is that's like getting a temperature without being given a temperature. So if you see standard temperature, it's the same thing as me telling you 273.16 Kelvin. Okay, so if you see the phrase standard temperature, you know it's 273.16 Kelvin. Okay, so here we have T2. So we've converted that. I already converted that by doing 67.84 degrees Celsius plus 273.16 gets me 341.00 Kelvin. So I've already converted that. My formula is P1T2 equals P2T1. P1T2 equals P2T1. I think I said that right the first time. And pressure is going to be 903.5 torr. T2, T2 is labeled here, so I've already converted. That's 341.00 Kelvin. P2 is what we're solving for. T1 was standard temperature, as we read that problem. So 273.16 Kelvin. What do I have 2 of? I have 2 temperatures. They're in the same unit, so then I can go on and proceed with my math. We're going to take 903.5 times 341, hit equals, divide by 273.16, and I should get 1127.89 torr for my final answer. Okay, the next example then. should be the example down there, 16, or whatever the fourth one is on Gay-Lussac page of notes. It says a gas at standard temperature, this is my T, and this is a pressure. Later has a pressure of this. This is just a typo. Okay, so these two are together. Standards with that based on how that's worded, so I'm going to make those my 1. By default, I'm going to make that my 2. Formula is P1T2 equals P2T1. I'm going to take 209.45 kPa times T2, which is what we're solving for, so that's my unknown, equals P2, which is 3456 atm times T1, which we have as standard temperature. Remember that temperature is always the difficult child, and you have to make sure you put it in the right spot. T1 goes over here. Okay, so T1 does not get to go with the other ones. So temperature is the problem child of the siblings, and it is not with the other ones. It's always on the other side. Okay, so what do I have 2 of? I have 2 pressures, but they're not in the same unit, so I'm going to convert one to the other. I'm going to do 0.3456. Doesn't matter which direction you go. I am choosing to go to ATM. Pardon me, I am choosing to convert from ATM to kPa. We know that there are 101.325 kPas per every 1 atmosphere, so atmospheres cancel. This is the conversion that we've been using for over a semester now. When I do that, I get 35.02 kPa. That is going to go where this is, so 35.02 kPa. Okay, so I replaced that and got that out of the way. I'm just going to move this down a little bit here so that you can see my math. Okay, so now I'm going to say, okay, I have 2 pressure units. They're now in the same unit, so I can use them. And now I'm going to multiply these 2 numbers. So 35.02 times 273.16 divided by 209.45 gives us a temperature. Let me get my marker working again. A temperature of 45.67 Kelvin. All right, that's all 4 examples of Gay-Lussac that are in your notes. Good luck with your practice problems.